Section 3.1, example 3 on page 169, we have noticed that the line in part A of problem 2 has a positive slope and slants upward from left to right. The line in part B from problem 2 has a negative slope and slopes downward from left to right. You can use any 2 points on a line to find its slope. Use subscripts to distinguish between 2 points. In the diagram, x1, y1 are the coordinates of point A, and x2, y2 are the coordinates of point B. To find the slope of line AB, you can use the slope formula. So the slope formula is rise over run, or y2 minus y1 over x2 minus x1, where x2 minus x1 does not equal 0, because we cannot divide by 0. The x-coordinate you use first in the denominator must belong to the same ordered pair as the y-coordinate you use first in the numerator. So if we look at example 3, it says, what is the slope of the line through -1, 0, and 3, -2? I went ahead and already labeled them x1, y1, and x2, y2, although this does not matter which one is which. So I could have called this x2, y2, and this x1, y1. What does matter is wherever I put my -1, my 0 needs to be right above it. Wherever I put my 3, my -2 needs to be right above it. So if we plug in y2, we get -2 minus y1, which is 0, over 3, which was x2, so make sure your point stays together, minus x1, which was -1. So minus a negative, make sure you have the parentheses around that negative. Now we're just going to simplify this. The numerator, -2 minus 0, is just -2. In the denominator, we have minus a negative, which becomes a plus. So we get 3 plus 1, or 4. 3 plus 1 gives us 4, and then we have -2 over 4, which simplifies to -1/2. So our slope of the line through -1, 0, and 3, -2 would be -1/2. The work for this problem is on the next few slides. Now I would like you to try to find the slope of the line that passes through each pair of points, and we have -6, 1, 4, 8.